Welcome to the next tutorial on electric power system. We are going to discuss the problems on Ybus or the admittance bus matrix. So let us revise some of the important concepts before solving the problem. The bus admittance matrix or Ybus can be found by inspection method using the following guidelines. So there are two different guidelines which will be used to compute the Ybus. The diagonal elements, that is Yjj, is given by sum of all the admittances connected to node J. So node J means a particular bus. So a particular bus, all the admittances connected together will just add up to find the element of the diagonal. The off diagonal elements will be computed by taking the negative sign. So we take a negative sign of the sum of all the admittance that is connected between the two nodes, node J and node K. So these two guidelines we are going to follow to obtain the Ybus using the inspection method. So let us see the problem number 1. In the problem number 1, we have been given a single line diagram of a power system where we have 4 buses. So the size of Ybus has to be 4 cross 4. Size of the Ybus will be 4 cross 4. Now obtain the bus admittance matrix, and second part of the question is determine the reduced admittance matrix by eliminating the node 4. So if one of the buses are removed from the system, that is the bus 4, will get a size of the matrix as 3 cross 3 for the Ybus. So all the reactances are given, or the admittances are given in per unit. So let us see. So in this problem, we have to first compute the diagonal elements. So we see the diagonal element. Now it is a 4 bus system. So the size of the matrix will be 4 cross 4. So first we obtain the element y11. So element y11 will basically the sum of all the admittances that are connected to it. So we can see that there are 3 elements which are connected, or 3 admittances which are connected, this and this, and that will form y11. Similarly, if we want to find y22, then only 2 admittances are connected to it. Y33 and Y44 will be formed similarly to following the guidelines 1. Guideline 2 will help us in following the off diagonal elements. So off diagonal elements, if we see, then element Y12 is basically all the admittances that are connected between the two nodes, or between the two buses 1 and 2. So here we can see that only one reactance is added between bus 1 and 2. Similarly, Y13 is basically the reactance that is added between element 13 with a negative sign. We know that the Ybus matrix is symmetrical, so y12 will be equal to y21. So if you see that y12 and y21, it is equal. Similarly, if you see y23 is equal to y32, so this element y23 will be equal to y32, and so on. If some admittances are not connected, then the value will be 0. So in this way, we can form the Ybus of this power system network. Now, in the next part of the question, we were given that 4th bus has to be eliminated. So this can be done by obtaining a new bus admittance matrix by eliminating the 4th row and the 4th column, which is given by yjk new is equal to yjk minus yjn into ynk divided by ynn, where n is equal to 4, which has to be eliminated, and j will be from 1 to 3 and k will be from 1 to 3. The bus admittance matrix is symmetrical, so ykj new will be equal to yjk new. So let us see how to obtain that. So y11, the first element we have to obtain, so it is equal to y1 minus y14, that is 1 into n, y41 divided by y44. So if we do that, we'll find a value. Now y12 new is equal to 1 y2 minus y14 into y42 divided by y44, that will give you a value. Now y13 new we have to calculate in the similar manner, and then we have to calculate, and we know that it is a symmetrical matrix, so y21 new is equal to 1 y2 new. Y22, that is the element we have to obtain, it is equal to similar manner y22 minus y24 into y42 divided by y44. So we can obtain y23 new, y31 is equal to y13 because it is a symmetrical matrix, and y32 is equal to y23. y33 now we can obtain with the similar manner, y33 minus y34 into y43 divided by y44. So the reduced bus admittance matrix after eliminating the fourth row is shown below. So this is the element which is equal to matrix of 3 cross 3. So the fourth row has been eliminated. Now problem number 2, you have to determine the bus admittance matrix of the system whose reactance diagram are shown. The current and admittances are all in per unit. So here we have been shown the current vector which is in per unit, and all the reactances are in per unit. So basically we have 4 nodes we have. So the size of the matrix has to be 4 cross 4. Now again we have to eliminate the node 3. So the size of the matrix will be 3 cross 3 because one of the node is reduced. Now, similarly, following the inspection rule with guidelines 1 and guidelines 2, we have to form the Ybus matrix. So, Ybus matrix first will obtain all the diagonal elements, and then we will obtain the off diagonal elements. So diagonal elements will be basically the sum of the admittances connected to a particular node, and off diagonal elements will be the negative of the sum of admittances that is connected between two particular nodes. So in this way we can form the Ybus of the system. Now you have to eliminate the node 3. So Ybus is rearranged by interchanging the row 3 and row 4, and then interchanging the column of 3 and column of 4. After interchanging row 3 and row 4, new Ybus is obtained. So you have to interchange the row number 3 and row number 4. So you will be obtaining this. So after interchanging column 3 and column 4, we will obtain this Ybus. So from the original Ybus, we have to first interchange the row number 3 and 4, and then we have to interchange the column number 3 and column number 4. Now the last row and last column, that is the fourth row and the fourth column of the Ybus matrix, can be eliminated. The new element will be obtained using this formula which we have used in the first problem. So here n is equal to 4 and j is equal to 1 to 3 and k is equal to 1 to 3. So let us obtain the elements. So element we have to obtain y11 new is again the admittance of 111 114 into 1 y41 by y44. So this is corresponding to the formula that we are using to obtain the new admittances. Similarly, we can obtain the y12 new, then we'll obtain the y13 new, and it is a symmetrical matrix. So y21 is equal to 1 y12. We'll obtain the y22 new and then y23 new, and then it is a symmetrical matrix. So y31 is equal to y13. y32 will be equal to y23, and y33 we are going to obtain. So we can obtain the reduced admittance matrix after eliminating the bus 3. So we can obtain this Ybus of the element. So this is obtained from the original Ybus matrix by eliminating node 3, which is obtained by first changing the row and then changing the column and then using the formula to update the Ybus. So in this way we can obtain the Ybus or admittance bus of any particular system using inspection method and further reducing the set of the matrix. Thank you.